Okay, let's talk about irrational numbers, but before we do that, let's talk about rational numbers. Okay, numbers are any numbers that can be written in the form a over b, where a and b are both integers. So examples would be 4 is a rational number because we can express that as 4 over 1, 2 over 3, minus 7 over 8, 0.45 is a rational number because we can rewrite that in the form a over b, 45 over 100, or 0.666 is a rational number because we can express that in the form a over b as 2 over 3. Okay, so now it's just to know that the decimal equivalent of a rational number, okay, like here and here, these are decimal equivalents of these rational numbers, either terminates and stops at a certain point, or it recurs, in other words, the numbers in the answer repeat. So, for example, if we have 7 over 8, that gives us 0.875, that terminates at that. 1 over 3 is 0.3333, well that keeps going on, it recurs that 3, so we just write 0.3 and we put a dot over top to signify that the 3 recurs. 3 divided by 11 is 0.27272727, so we write that as 0.27, where we're kind of noting with the double dots, the 2 dots, that the 27 recurs. Okay, so there's a dot above the first and last digit of the recurring group, that is 2727. 7 over 12 is 0.58333, and this 3 will keep recurring, so we'll write that as 0.583 with a dot on top to say that it's this 3 that will keep recurring. Now let's talk about the notion of perfect squares. So the square root of 1 is 1. 1 times 1 is 1. It's an exact number. Square root of 4 is exactly 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. They're all exact numbers. These are known as perfect squares. Okay. Now let's talk about non-perfect squares. The square root of 2, it's non-repeating and it's never ending. The square root of 3 is the same. Square root of 5, non-repeating and never ending. These are known as irrational numbers. They never end and they're non-repeating. Okay, and these root 5. Okay, this is this irrational number here, expressed in third form or as a third, is expressed like this. So this is the irrational number, and this is how it's expressed in third form or as a third. Okay, so for example, the irrational number 2.23606797, I've gone on and on and on, expressed as a third is the root 5. Okay, and we just mentioned here that that numbers, they can have 2 parts. So if we think of the number that is root 5, it's a third, okay, we can, recognize or note that root 5 is the same as 1 times root 5. And, basically there's 2 parts to that number, root 5. There's this rational part of the number, 1 root 5, and that's the 1. And then there's this irrational part here, which is the root 5 part. Okay, so just to note that thirds and numbers can have 2 parts, a rational and an irrational part.